Greetings students. In our Tier 2 Unit C, we were discussing about factors and multiples. As I have already told you, I have divided this chapter into three parts. This is the third and a final part of those three. This is for class 6. The subject is mathematics. I am Sivasis Sandilya and I welcome you to today's class. So these were the subtopics that we were discussing till now. The last subtopic, solving problems using the relation between LCM and HCF, that we will discuss today. Apart from that, almost everything we have already discussed in our previous videos. So we are going to directly start the modules. Till now, out of the 20 modules that the chapter has, we have completed 15. Today we are going to start with module number 16 and move on to module number 20 and conclude the chapter. So module number 16, state whether the given pair of numbers are coprimes or not. Now, a quick reminder of what are coprimes. You have already learned about coprimes in your class 5. But still, this is a quick revision. Look at the blue box on the right hand side of the screen. Numbers having no common factors other than 1 are called coprimes. Any two numbers which have no other common factor except 1, they are coprimes. Now look at the demo number 1. You have to state whether 20 and 22 are coprimes or not. Now, when we prime factorize 20, we get 2 into 2 into 5. And when we prime factorize 22, we will get 2 into 11. Now, the HCF is 2 because the highest common factor is 2. Thus, these two numbers are not coprimes because 2 can divide both 20 and 22. So they have a common factor other than 1, that is 2. So they are not coprimes. Look at demo number 2. 9 and 14. When we prime factorize 9, we will get 3 into 3. And when we will prime factorize 14, we will get 2 into 7. Now there is no common factor. So the HCF will be 1. That means 9 can be divided by 1, 14 can be divided by 1. Other than 1, there are no common factors. So, as there is no common factor other than 1, so 9 and 14 are coprimes. In the same way, pause the video for 10 minutes. Do all the 4 problems in module number 16 by yourself. Now these are the answers to module number 16's question. Let us discuss question number B, 12 and 21. So when we prime factorize 12 and 21, for 12 we will get 2 into 2 into 3 and for 21 we will get 3 into 7. Now there is a common factor 3. So the HCF is 3. Since 3 can divide both 12 and 21, they have 3 as a common factor other than 1. Thus, 12 and 21 are not coprimes. In the same way, note down the correct answers. If you have any doubt, please contact me. Now, in module number 17, find the HCF of the given number by prime factorization method. So, what we will do, look at the demo. We have to find the HCF of 154 and 210. So, first of all, we will prime factorize 154 separately, 210 separately. And we will get 154 equal to 2 into 7 into 11. And 210 we will get as 2 into 3 into 5 into 7. So the common factors are 2 and 7. Thus, the HCF or the highest common factor will be 2 into 7 equal to 14. In the same way, pause the video for 15 minutes. Do all the problems in module number 17. Now, before you start, look at question number D. There are 3 numbers. You have to prime factorize each of those 3 numbers separately, then find the common factors. Now pause the video for 15 minutes. Try to do this yourself. Even if you do it wrong, don't worry, I will show you the correct answers. So these are the answers to question number A and B. I hope everyone did everything correctly. If you have done anything wrong, pause the video, note down the correct answers. And these are the answers to question number C and D. Let us discuss question number D. When we prime factorize 156, 276 and 396 separately, we will get 156 equal to 2 into 2 into 3 into 13. 276 is equal to 2 into 2 into 3 into 23. And 396 is equal to 2 into 2 into 3 into 3 into 11. So the common factors in all these numbers are 2, another 2 and a 3. So 2 into 2 into 3 gives you 12. Therefore, the HCF of 156, 276 and 396 will be 12. Pause the video, note down the answers, and if you still have doubts, please contact me. You know my phone number, you know my WhatsApp number. Contact me, I will help you out. Moving on, module number 18, find the HCF by the division method. So how will we do the division method? Look at demo. We have to find the HCF of 49, 91 and 105. So first of all, what we will do, we will divide the second largest number by the smallest number. Here the second largest number is 91 and the smallest number is 49. So we will divide 91 by 49. So 49 ones are 49. Subtracting 91 minus 49, we will get 42. Now we will divide the original divisor, that is 49, by this remainder, that is 42. So 49 divided by 42, again 1 times 42, subtraction, 7 remains. Now this 7 will be used to divide the previous divisor, that is 42. So 42 divided by 7 will give you 6. Now we will consider the last divisor, that is 7, and divide 105 by that divisor. So 105, look at the second part, that is the right hand side of the screen of the demo part. 105 divided by 7 will give you 15. Since 7 has completely divided 105, so the HCF of 105 and 7 is 7. And look at the left hand side. Since 7 has completely divided 42, so the HCF of 49 and 91 is 7. Thus, the final concluding sentence will be the HCF of 49, 91 and 105 is 7. If you need more time, pause the video, note down the demo. Once you do it with your own handwriting, it will be clearer to you. Still, if you have any doubt, please contact me. In the same way, pause the video for 15 minutes. Do all the 4 problems in module number 18. Now, let us move on to the answers. So, these are the answers to question number A and B of module 18. Pause the video if required and note down the correct answers. If you have already done everything correctly, then very good. And these are the answers to question number C and D. Pause the video, Note down the correct answers. In question number D, look at the third number. It should be 539. It is misprinted as 1539. Please correct it and then note down the answers. If you still have doubt, please contact me. I will help you out. Now, module number 19, problems based on LCM and HCF. Look at the demo. Find the greatest number which divides 597 and 842, leaving remainders 3 and 5 respectively. So, look at the answer to the right hand side. The required greatest number is the HCF of 597 minus 3 equal to 594. Why? Because this number that we have to find out, when it will divide 597, it will give a remainder of 3. That means if we subtract 3 from 597, we will get 594. Then this number that we have to find out will divide 594 completely. In the same way, the number that we have to find out will divide 842 and leave a remainder of 5. So if we subtract 5 from 842, we will get 837. Then this number that we have to find out, this number will divide 837 completely. Simple. So now we have to simply find the HCF of 594 and 837. Now, though the demo is showing you that they are doing the division method, if you want, you can do the prime factorization method also. If the method is not specified, you can use any method. If the answer is correct, you will get the marks. Don't worry about it. Now, after that, once we are clear that now we have to find the HCF of 594 and 837, proceed with any procedure, either the prime factorization method or the division method, and finally you will get the HCF as 27. So the required greatest number which divides 597 and 842, leaving remainders of 3 and 5 respectively, is 27. In the same way, let's try to do all the problems in module number 19. Question number A, find the greatest number which divides this and this, leaving remainders 5 in each case. So first of all, you will subtract 5 both from 381 and 817. Then whatever two numbers you will get, you will find the HCF of those two numbers. A team of players can be divided into groups of 5, 6, 8 and 10. What is the least number of players this team can have? So what you will do, you will find the LCM of all these four numbers, 5, 6, 8 and 10. What is the smallest number which when divided by 24, 48 and 84 leaves remainder of 3 in each case? So try to do this yourself. Question number D, two tanks contain this much and this much liter of water respectively. Find the maximum capacity of a container which can measure the water of either container in exact number of times. Think about it. You have to find the LCM or HCF and try to do it yourself. Pause the video for 15 minutes. Do all these four problems. Now let us move on to the answers. So question number A, see, required greatest number is the HCF of 381 minus 5, that is 376, and 817 minus 5, that is 812. Proceed with any method, either the division method or the prime factorization method, and you will find that the answer is 4. The HCF is 4. Question number B, the least required number is the LCM of those four numbers, and you will find out that the LCM is 120. Pause the video if you need more time and note down the answers. These are the answers to question number C and D. The required smallest number is the LCM of these three numbers plus 6. Plus 3. So first of all we will find the LCM of 24, 48 and 84, which is 336. Adding 3 to it, we will get 339. And this is the smallest number that when divided by 24, 48 and 84 leaves remainder of 3 in each case. Question number D. First of all, we will divide 575 by 184 and we will get a remainder of 23. Now this 23 will be used to divide 184 and it will completely divide 184. So the HCF of 184 and 575 is 23. Therefore, the required maximum capacity of a container is 23 liters. Pause the video if you need more time and note down the correct answers. Now, relation between LCM and HCF. When we have two numbers, we can find the LCM of those two numbers and we can find the HCF of those two numbers. Now, if we multiply both the numbers, then it will be equal to the multiplication of HCF and LCM. For example, if we have two numbers A and B, then we can say A into B will be equal to HCF of AB multiplied by LCM of A and B. Using this relation, now we are going to solve all the problems of the next module, that is module number 20. This is the final module of the chapter. Solve the following using the relation between LCM and HCF. Look at the demo. The HCF and LCM of two numbers are 18 and 180 respectively. If one of the number is 36, find the other number. So the equation was one number into other number equal to HCF into LCM. Therefore, the other number will be HCF into LCM divided by one number. This is just cross multiplication, okay? Now we will just put the values. HCF was given as 18, LCM was given as 180 and the first number is given as 36. So 18 into 180 divided by 36, we will get 90. Therefore, the other number is 90. In the same way, pause the video for 15 minutes and do all the 4 problems in module number 20. Now let us move on to the answers. So these are the answers to question number A and B. Simply use the equation, that is one number into the other number equal to HCF into LCM, and these are very easy to find answers. Pause the video if you require more time and note down the answers. These are the answers to question number C and D. Same method. If you need more time, pause the video and note down the correct answers. So basically, today we have done module number 16, 17, 18, 19 and 20. So this completes unit C, that is factors and multiples of tier 2. This brings us to the end of today's class. I hope everyone enjoyed today's class and understood everything that I have taught. In our next class, we are going to start unit D. At this point, once again I am reminding you, please revise carefully all the problems several times. With this note, I am Sivasis Sandilya signing out. Thank you everyone for watching.